Hydropower, or hydroelectricity, generates electricity by capturing the energy of flowing water. Although it seems like capturing energy from moving water would be a complex process requiring modern technology, hydropower has actually been used for thousands of years, making it the oldest form of renewable energy. Dating back to the 1st century, the Greeks used water wheels to grind their wheat into flour. Later on, the Greeks' water wheels became popular in early first millennium England, where more than 5,000 water wheel driven mills were in use, about one for every 400 people. The world's first hydroelectric power plant utilized the flowing water of the Fox River in Appleton, Wisconsin, beginning its operation on September 30th, 1882. 4 years later, about 200 hydroelectric power plants sprung up across the United States. By the 1940s, hydropower was providing 40% of all electrical generation. Today, electricity generated through hydropower makes up 67% of all renewable energy output. Hydropower generation makes up the majority of all renewable energy electricity output due to its popularity, especially in China, Canada, Brazil, the United States, and Russia. Its popularity can be accounted for by the many advantages of using hydropower. First, there is the availability factor. Hydroelectricity only requires moving waters such as rivers, streams, and ocean tides to generate electricity. While water is not an unlimited resource, it covers 71% of the Earth's surface. Thus, as long as water is conserved and used efficiently, hydropower can continue to be used to create electricity worldwide. The second advantage to utilizing hydroelectricity is its reliability. The demand for electricity can change rapidly, yet hydropower facilities can quickly go from zero power to maximum output, easily catering to these changes. Developing countries manage to function without electricity, but for the majority of the world, it has become a necessity. Hydroelectric power plants are invaluable sources of backup energy because they are the only major generators that can dispatch power to the grid immediately when all other energy sources are inaccessible. This phenomenon was seen in the 2003 blackout, which affected an area from New York to Michigan, leaving 50 million people without electricity. The Niagara Falls and St. Lawrence hydroelectric plants restored power almost instantly, an operation called Black Start, which is the ability of hydropower plants to resume operations in isolation without drawing on an outside power source. The third advantage of hydropower is its affordability. The figure below, provided in 2010 by Navigant Consulting Incorporated, compares the cost of maintenance, operations, and fuel for various sources of electricity. Hydropower is the least expensive, costing only 2 cents per kilowatt hour. In comparison, the most expensive source of electricity is photovoltaics, which cost 16.5 cents per kilowatt hour. Hydroelectric power is affordable because it generates electricity only from moving water. Thus, prices don't depend on unpredictable changes in fuel costs. Finally, hydroelectricity is sustainable. Countries use hydropower because it does not pollute the air, nor does it produce any toxic byproducts. Without the use of hydropower, nearly 200 million metric tons of carbon pollution would be released into the air, which is equal to the output of over 28 million passenger cars. The map below illustrates the United States 2002 carbon emissions. In the Midwest to West Coast region, where hydroelectric power plants such as the Grand Coulee Dam and Hoover Dam are located, it can be seen that the level of CO2 emissions are much lower than that of the East Coast region. With the numerous benefits of hydropower, it is easy to see why it is the major source of renewable energy worldwide. But how does it work? There are three types of hydropower plants: impoundments, diversions, and pumped storage facilities. Impoundments, the most common type of hydropower, use dams to trap flowing water in a reservoir. When the water is released from the reservoir, it flows through turbines, activating a generator that then produces electricity. An example of an impoundment is Glen Canyon Dam. Located on the Colorado River, Glen Canyon Dam provides 4.5 billion kilowatt hours to Arizona and the surrounding area. Diversions are similar to impoundments, yet instead of using a dam, water is directed through a canal or penstock. A pumped storage facility works slightly differently than impoundments and diversions. Instead of providing instantaneous energy, Pumped storage facilities store energy by pumping water uphill to a reservoir at a higher elevation from a second reservoir at a lower elevation. When the demand for electricity is particularly high, the water can be released from the upper reservoir to the lower reservoir, and then pushed through turbines, generating whatever amount of electricity is needed. Hydropower requires man-made construction on bodies of water. Thus, although there are many advantages to its utilization, there are also disadvantages. The first disadvantage is the environmental damage that can occur with the installation of dams. Flora and fauna in the surrounding areas of the dam are not equipped to live in such a flooded area, and the disturbance can cause them to relocate or simply die out. In addition, although the costs of maintaining and operating hydroelectric power plants are low, it is expensive to build the initial facility. The cost of building hydropower plants prohibits many developing countries from beginning construction, though they potentially could. Hydropower generates 20% of the world's electricity. It gains popularity daily due to its numerous benefits. Although developing countries currently have limited ability to construct hydroelectric power plants, I believe that the world's push towards sustainability and conservation will eventually make hydropower accessible to all countries, significantly raising the percentage of electricity generated through hydropower.